When adding two three-way dimmers to an existing electrical system, it's crucial to understand the code requirements regarding neutral conductors. Although the immediate wiring plan might not utilize a neutral wire, many jurisdictions mandate that a neutral conductor be run with all hot conductors. This means that even if you don't intend to connect the neutral to the three-way dimmer circuit itself, you may still be obligated to include it in the conduit run and terminate it appropriately within the electrical boxes. This requirement stems from the broader principle of ensuring a complete and safe electrical system, anticipating potential future modifications or additions. Firstly, consider the specific electrical codes applicable to the location. Jurisdictions often adopt or adapt the National Electrical Code, also known as NEC, but local amendments can introduce variations. These local codes may explicitly require a neutral conductor in all new circuits, regardless of the immediate load requirements. To determine the precise requirements, consult the local electrical code or speak with a certified electrical inspector. Secondly, the presence of a neutral conductor can mitigate potential electromagnetic field, also known as EMF effects. While the current in a balanced circuit ideally cancels out, EMF imbalances can occur, leading to unwanted electromagnetic radiation. A properly grounded neutral conductor provides a return path for any stray currents, minimizing the EMF emissions from the wiring. Thirdly, installing a neutral conductor future-proofs the electrical system. As the original question mentioned, incorporating a capped-off neutral wire provides the option to easily add a standard electrical outlet or other 120 volts device to the circuit in the future. This can save significant time and expense compared to running a new circuit from the panel. From a practical standpoint, when running new ENT conduit from the existing 5S box to the new location for the three-way dimmers, include a neutral conductor in the conduit along with a hot conductor, ground conductor, and two traveler conductors. Terminate the neutral conductor in the electrical boxes at both ends, even if it is not immediately connected to any devices. Use wire connectors, such as wire nuts or terminal blocks, to safely cap off the end of the neutral conductor, ensuring it is insulated from accidental contact. If adding a receptacle in the future, simply connect the neutral conductor to the neutral terminal of the receptacle. Understanding the rationale behind the neutral wire requirement can also inform decisions about electrical system design. While it might seem unnecessary to include a neutral when it's not actively used by the current circuit configuration, the code requirements and future-proofing benefits often outweigh the incremental cost and effort of including it. Moreover, certain types of dimmers and smart switches require a neutral connection to operate correctly. By including a neutral conductor in the initial wiring, future upgrades or changes to the lighting system can be accommodated without requiring new wiring runs. Additionally, consider the implications of not running a neutral conductor. If the local code requires it and an electrical inspection reveals its absence, the installation may fail inspection, requiring rework and potential delays. It's always advisable to err on the side of caution and include a neutral conductor when in doubt. In summary, while it might seem counterintuitive to run a neutral conductor when it's not explicitly needed for the immediate operation of a three-way dimmer circuit, code requirements and the potential for future use often make it a prudent and necessary step. By consulting local electrical codes, understanding the reasoning behind the neutral wire requirement, and planning for future needs, you can ensure a safe, compliant, and adaptable electrical installation. Now let's talk about some additional points regarding the installation and the importance of adhering to electrical codes. When dealing with electrical wiring, safety should always be the top priority. Firstly, before starting any electrical work, always turn off the power to the circuit at the main electrical panel. Use a non-contact voltage tester to confirm that the circuit is energized before touching any wires. Secondly, wear appropriate personal protective equipment, including safety glasses and insulated gloves. Thirdly, ensure that all wiring connections are made properly and securely. Loose connections can cause overheating and create a fire hazard. Use the correct size and type of wire connectors for the application and tighten them to the manufacturer's specifications. When running EMT conduit, use appropriate fittings and connectors to ensure a secure and grounded connection. This helps to protect the wiring from physical damage and provides a path for fault currents to flow back to the source, tripping the circuit breaker and preventing electrical shock. Regarding the selection of wire size, consult the National Electrical Code, known as NEC Table 310.15 for ampacity ratings. The ampacity of the wire must be sufficient to carry the maximum load of the circuit, plus any anticipated future loads. It's always better to err on the side of caution and use a larger wire size than is strictly required. For example, for a 15 amp circuit, use at least 14 American wire gauge, also known as AWG, copper wire. For a 20 amp circuit, use at least 12 AWG copper wire. When pulling wires through ENT conduit, use a lubricant to reduce friction and make the job easier. Avoid pulling too many wires through a single conduit, as this can damage the insulation and make it difficult to troubleshoot problems in the future. The National Electrical Code, known as NEC, specifies the maximum number of wires that can be installed in a given size of conduit based on the wire size and type. When terminating wires at switches, dimmers, and receptacles, use the correct terminals and tighten the screws securely. Do not over-tighten the screws, as this can damage the terminals. If the device has pushing terminals, ensure that the wires are fully inserted and locked in place. When installing dimmers, use dimmers that are compatible with the type of lights being controlled. For example, some dimmers are designed for use with incandescent bulbs, while others are designed for use with LED bulbs. Using the wrong type of dimmer can cause flickering, buzzing, or premature failure of the bulbs or the dimmer itself. When connecting ground wires, use green insulated wire connectors or bare copper wire. Connect all ground wires together into the metal enclosure of the electrical box. This provides a path for fault currents to flow back to the source, tripping the circuit breaker and preventing electrical shock. When installing electrical boxes, ensure that they are securely mounted to the wall or ceiling. Use appropriate screws or anchors for the type of material being mounted to. Do not leave any exposed wiring outside of the electrical boxes. Finally, after completing the electrical work, test the circuit to ensure that it is working properly. Use a multimeter to check the voltage and current, and verify that the ground fault circuit interrupter, known as GFCI, protection is working correctly. If you are not comfortable performing electrical work yourself, hire a qualified electrician to do the job. Electrical work can be dangerous, and it's always best to leave it to the professionals. By following these guidelines and adhering to electrical codes, you can ensure a safe and reliable electrical installation.